Hi, and welcome back to Math 520, and welcome to week 9 of the semester. This week, we're going to talk about Chapter 6 of Axler. We're going to start Chapter 6 of Axler, because Chapter 6 is going to be yet another hefty chapter here. So this week, we will look at sections 6a and 6b, and then next week, we may revisit 6b a little bit more, and then do 6c. And I should mention that the content of this section is, of this chapter, overlaps very much with the content of Treil, Linear Algebra Done Wrong, his book's chapter 5. Okay, so the key idea from this section for this week and next week is the idea of what's called an inner product. So an inner product is a generalization of the dot product that you know and have worked with in your calculus classes and in your first linear algebra class. Now the dot product is something that makes sense for R2, R3, actually in general for Rn. So what we're going to talk about is a large class of things that generalize the dot product, both on Rn but also in Cn and also on an arbitrary vector space. We'll give some axioms for it and see what comes out of these axioms and these requirements for an inner product. And closely related to the inner product is a notion called a norm. A norm on a vector space is, you can think of the most basic one in both the plane and in space, coming to you by taking the square root of the sum of the squares of the entry of your vector, right? It's the length of the vector. Well, that also we're going to look at and see how that comes into, sort of fits into a more abstract framework. Now, both of these ideas are important geometric ideas, right? The idea of a dot product, if you remember back from your previous encounter with the dot product, that you can write down a formula for the dot product of two vectors, but you can also think of it as a projection operator, or as something that gives you a cosine of the angle between your two vectors. So in that sense, the inner product on a vector space is going to contain inside of it this geometric knowledge of lengths of vectors and also of angles between vectors. And as we know, angles are a very important geometric property. So this is something where we're starting to really see some deep geometry showing up in our linear algebra. Let me make a side remark here. So the side remark is there's another product that you know from, let's say, from calculus. And that other product is called the cross product. Now the cross product is something that is very specifically three-dimensional. And there's some deep algebraic reasons for that, but it's much more difficult to understand. It's a much more delicate object than the dot product is, right? So the cross product is much more subtle, and we will not be generalizing that in this class. That's a topic for other classes and other days. Okay, for course mechanics, we have the written homework is due on Wednesday, as always, and you also have your discussion forum post. The first one is due Wednesday evening at 11:59, and then this coming Sunday you have two follow-up that are due if you're a graduate student and one follow-up due if you're an undergraduate.